Hello students, here we are discussing about electric current. In electric current, in just in a basically means the previous classes. So uh, just we discuss about electric current. I is what the flow of charge per unit time. Okay, so flow of charge per unit time, like we can say. If we discuss in detail about electric current, so if I talk about, there is a conductor, so it's a metal body is taking as this, it's a metal rod. So metal rod has free electrons. So these are the free electrons. Free electrons, they are like this. They are the free electrons. Instead of this one, if we choose about any like a wood piece of wood, so it has no free electrons. That's what it is, a insulator. We know it. So these free electrons randomly they move in different directions. They move in different directions. So like a random motion. Okay, so this is random motion of free electrons. So this here random motion of free electrons, random motion of free electrons. So this is known as Brownian motion. Brownian motion means what? They are moving in three-dimensionally in all the directions in the metal. So slowly, when they are electrons, these electrons are moving like, okay. So slowly, the electrons they carry the energy. Electrons move randomly. So they move in a randomly in all directions. And so the energy of electrons due to thermal agitation. So what is the thermal agitation? So due to collision, so heat is developed due to friction, like heat is developed. So they are moving from in all the directions. So due to thermal agitation, so the direction in different ways we can say. Thermal agitation means what? Heat is developed due to collision when they are moving like randomly. So one is collided with another one. So like due to friction, the heat is generated. Okay, next one. So here, this in this situation, when potential difference is applied, between the ends of rod. So when you apply the potential difference, something I'm applying, this is positive and negative, like potential difference is created. Its potential is V. This is positive, negative, high potential, low potential. Immediately, electric field is created from the positive to negative. This is electric field. When electric field is created, electrons direction is opposite direction to the direction of electric field. So electrons, the force acts on this. The force on the electrons will be acting along with the positive terminal towards the positive terminal, like so. This is here minus EQ. You know it. It's a minus EQ. Like minus EQ. So next one, when this, for example, if I choose about there is some any cross-sectional area, this is due to cross-sectional area. So through this given cross-sectional area, how many charges are moving? How many charges are moving? So these electrons are in towards you here, and positive charges are in the opposite direction to this one. So how many charges are moving? So that is what it's a current. I is equals to Q by T. It's I is equals to Q by T. So then we can say as this current, electric current, so is net flow of charges, per unit time. So net flow of charges per unit time, I is equals to Q by T, which is NE by T. So N is the number of electrons. E is what? It's a charge of electron, which is 1.6 into 10 to the power of minus 19. So it's a current. It's a, when current is passing, means when a charged particle is moving in circular path, the charged particle is moving in circular path, its radius is r, this is its velocity v, is in the direction. Okay. Current I is equals to net flow Q by time taken. The time taken is what? Capital letter T. So it's what? Time period. So this is T. T is equals to 2 pi by omega. So this we can say it's a QF, correct? Then next one is Q. So this is what? 2 pi by omega. Omega means V is equals to R omega. Omega is equals to V by R. So then I is equals to QV by 2 pi R. So when a charged particle, so when an electron is moving in a circular path around the nucleus of an atom, okay, so I is equals to QV by 2 pi R. So the current produced is that V stands for velocity of charge, R is, it's a radius.